Hi, welcome to the pre-calculus lecture series. And in today's video, we're going to cover section 5.4. We're going to cover the graphs for the remaining 4 trig functions here. We're going to talk about the graph for the tangent, cotangent, secant, and the cosecant. In our previous video, on the section 5.3, we covered detailed in the sine, cosine. So we will continue here with our remaining 4. Okay, so now let's go to our lecture notes here and start to take a look. How do we do this here? Okay, so the first thing is just like the sine and the cosine here. Let's take a look at what is the periodical property for these 4 functions here. Okay, so for both tangent and cotangent, so both tangent or cotangents, they have what? They have a period is equal to pi here. That is the different than the remaining 4. So like the 4 others ones here, like sine, cosine, secant, cosecant, they all have a period is 2 pi. And in here, the tangent and the cotangent, their period is pi here. That means in here, the tangents here, the x plus pi, and will be equal to the tangent, what, x, right? So the same things for the cotangent, x plus pi, it will be equal to the cotangent, what? It will be the cotangent x here. And then for the, okay, so let's take a look at the, for both secant and cosecant. So they have a period because we know the secant is the reciprocal of cosine, cosecant is the reciprocal of the sine. So both of them have what? Have a period is what? Is 2 pi, right? Okay, so here be careful, the both of here is 2 pi. So just like we defined the secant and the cosecant, right? So we will say the cosecant, the x plus 2 pi. So every time you do a 2 pi, it will just be equal to the cosecant x. And then the secant here, the x plus 2 pi will be equal to what? It will be equal to the secant x here, right? So that's what we mean the 2 pi's here. So let's take a look at the graph, you know, for the sine and cosines. I'm sorry, the tangent cotangents here, right? So in here, let's take a look here. So for the tangent and the cotangents here. So this is the tangents, right? So remember the period is pi. So in here, if I do like this, so this is the pi over 2. This is pi. This is negative pi over 2. This negative 2 pi. So if you use the unit circle and go ahead to graph the tangent x here, you will see this is what is our tangent x. So in here, this is my tangent x here. This is the whole period from negative pi to pi over 2 here, okay? And now because like, so I'm going to use the different color. That's to show you how they repeat their period. So this one, you know, is equal to, you know, you add ones, right? So this is how they repeat their period here, right? So in here, how do they do that? So this is how they repeat their period. Okay, so that's what we call this, the, you know, the tangents ones here. So as you can see, the tangent, you know, their asymptote is where? their asymptote is all at the pi over 2 or 3 pi over 2 or negative pi over 2, right? So this is we call this is the tangent graph, right? Okay, so tangent x. Okay, so now let's take a look the cotangents here, right? So this is my cotangent axis here. So it's pi over 2 pi. Okay, so I'm going to show you how they repeat, right? So this is a pi over 2 pi, 3 pi over 2. And then this one is negative pi over 2 and the negative pi's, right? So let's see here. So those my asymptotes here. Okay, so if you use the value of the unit circles here, you will find the cotangent pi's here, right? So cotangents here, you know, these ones here are going to go like this. Okay, so that will be my cotangents here, right? Okay, so now I'm going to use the different color to show you how they repeat, right? So the way they repeat are going to be like this. Correct? And then this is how they're going to repeat. Okay, so this is the cotangent. And be careful, you know, if you take a look, you know, you will say, what, you know, you hear the color I use here, make sure you kind of remember this is the color I'm using here. And because in the, you know, when we go to the next sections, we talk about the inverse. So this will be the region we're going to use for our inverse. But that is what is the tangent, right? So they repeat the pattern at the pi, all right? So now let's take a look. Okay, so let me see here. Yeah, let me move this one down a little bit. And so we can have a little bit of space for the, we have a little bit more space for the tangents here. Oops, what did I do here? All right, so the here, okay, let me get a little bigger. Okay, so good, all right. Okay, so now for the, okay, so let's take a look for the secant and the cosecants here, right? Let's take a look at the cosecants here. We know the cosecant is the what? Is the reciprocal of sines, right? Okay, so this is 1, 2, 3, 4, 1, 2, 3, 4. I mean, so this is a pi, this is a 2 pi, this is a pi over 2, this is a 3 pi over 2, this is negative pi over 2, negative pi, negative 3 pi over 2, and the 2 pi. So I'm going to do sine function first, right? So this one, we all know this is my sine functions, right? Okay, so this is my sine functions here. All right. Okay, so now this is my main part of my sine function. And because the cosecant, so this is the cosecant x, is the what? Is the reciprocal, right? So that means this one's here, I'm going to use my color code here. So this is ones, right? Okay, so this is the 1. That means here's approach to 0. So that's why I know my cosecant going to go like this, going to have an asymptotes here. And the same ways here. Let me try to put this ones here and try to put this ones here, right? Okay, so this is my cosecants here. Okay, and the same way, this one going to flip down here, right? Going to flip down here. So the cosecant is going to have what? It's going to have the asymptote at the pi and the 2 pi. Also, the cosecant does not have a magnitude, the amplitude, right? Because it's go to infinity, just like a tangent and cotangent. Okay, so now let's see how the cosecant repeat, right? So the same ways here is how your, how is your sine. So this is your sines, right? So your cosecant, we're going to repeat it just like in here. We say here, this is going to repeat like this, and this is going to repeat like that, right? So this is what we call this the cosecant. So let's take a look at the same ways here. So the same way, if I'm going to do the secant, right? So this is 1, 2, 3, 4, 1, 2, 3, 4. So this is negative pi over 2 pi, 3 pi over 2, 2 pi, negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi. Okay, so we know the secant. So let's draw the secant function first. The secant is go like this, right? We say the secant is go like this and go down here. That is the one period for the seconds here, right? Okay, so now let me try to draw this is cosine, I'm sorry. So let me try to draw the seconds here. This is a cosine, all right? All right, so here, this is a cosine. If you want, you can do like more here, right? Okay, so this is a cosine. So let's draw the main part for the seconds here. So it start here, right? So now this one going to approach to 0. So the secant go like this. And this one's here is right, is flip down, right? And this one's here is going to flip this way, right? So this is the main part of the secant. So if you want to see how the secant repeat will be the same things here, you put your asymptotes here. Okay, so the secant going to repeat like this, right? So it's going to go like this, and here go like this, and here is go like this, right? So let's work the secant graphs here. So if you find if you find the cosine and the secant is reciprocal, that's how the graph is here. The way I use the blue, that is the main things, right? We're going to talk about, in the next sections here, when we talk about the domain of the inverse functions here. So here, this is the one I have here, right? Okay. Right. Okay, so now let's take a look. So how do I graph the, so let's see here. Okay. So the first thing here, graph each functions here, right? All right, so for the graphs here, let's take a look. How do I graph the seconds here? So remember, this is the parent functions, right? So the one I highlight in the blue, this is my parent function. I highlight in the yellow, this is my parent function. So we have a few key points to remember. So this is zeros here. So we have zeros here. Then this one's here is a pi over 4. Pi over 4, I have 1 here. Just like this is a negative pi over 4. But I have here, I have negative 1s here. Right, so this is a point. I have negative 1s here. All right, so now let's take a look. How do I graph the first one, the tangents here? All right, so here, okay. So go to your parent functions. So the parent functions here, this is a pi over 2, this is a pi, right? So this is a pi over 2, this is a pi. And then this is a negative pi over 2, this is a negative pi, right? Here's 1. Here is a pi over 4, pi over 4. So I know my parent function going to go, maybe this is a little too high here. Okay, so this is my parent functions going to go. So here, this is a pi over 4, this is 1, right? So this is a pi over 4. So this is one of the key point we're going to what? We're going to here, right? So it's pi over 4 and 1. We're going to graph with our function. So the next ones here is negative ones, right? So the here, so going to go down here. So this is negative pi over 4. So this point is negative 1. So those are my two key points here, right? So it's 1 and negative 1. So 2x, that means I'm just times 2. So when the x equal to 0, so I'm still at the point. When the x equal to pi over 4 used to be 1, now I times 2, so it's 2. So it's this point here. So my function will be like this. It is still going to approach to the asymptote at a pi over 2. So the same way is here, right? The times 0 is 0, times negative 1 is negative 2. So this will be my tangent, 2 tangent x. So this is 2 tangent x here. I kind of stretch a little bit. Okay, so now the next one's here. This is the negative tangents here. Okay, so here this is the pi over 2, pi, negative pi over 2, negative pi. Okay, so I'm still do my parent functions here. My parent function, all right, so it's a pi over 2, so it's like this. Right, so this is a pi over 2, this is a negative pi over 2. Or you can do like this. This is my parent function. Okay, so now you have a negative sign. What's that mean? That means you flip over what? X-axis, right? Okay, so now this point, so your final graph is going to look like this. Then this one flip over here, right? So now this one flip, so if you want to repeat your graph, so here, and this one's what? Repeat like that. Right? So I know from the parent function, so this one's here, I also have a parent function like this, right? So if you want to graph this one, so what you're going to do here, so this is going to be repeated like that. So this one is negative tangent x here, you're reflecting over the x-axis. So for the y scale, you can do a stretch or reflecting, or you add, or add some numbers moving up and moving down. It's pretty easy. Okay, so now we want to take a look at the period for this tangent and cotangents here. All right. Okay, so now let's take a look at the here. So if the functions here, right? So for the function, okay, so if y is equal to the a tangent kx, okay, or the y is equal to the a cotangent the kx, because both of them has the period as pi, so both of these functions have a period equal to what? Is equal to pi over what? Pi over k here, right? Okay, so be careful, just like we did for the sine and the cosine, but right now the parent function, the period is pi. So this one is really is a horizontal stretch or shrink, right? So now, how do we graph it? Okay, so let's take a look at how do we graph this ones here, right? Okay, for the tangent 2x here, so the step, just like we did before, okay, so let's see here, tangent 2x here. So what is the period here? So the period will be what? Period will be pi over 2, right? So period are going to be pi over 2. Okay, so then what you need to do is here, you divide period by 2. So what is going to be pi over 4? That means on each axis, you're going to have a pi over 4 here. So that's how do you graph it, right? So this is tangents, right? So this is a pi over 2. This is a pi. This is a negative pi over 2. This is what? This is negative pi, right? So now in here, we say, hey, my period shrink to the pi over 2. So that means for each one, my asymptote going to be at a pi over 4 here. So pi over 4 is right in between here, right? So that's why you find the asymptote. So that's why what is your tangent function going to look like? Your tangent function going to in between these two intervals here. Right? So now every pi over 4, you can have an asymptote, right? So if I say, hey, do the repeated tangents, right? So how do you do that? As soon as you have the main one down, then you can say, okay, the repeated tangent, this is a pi over 4, right? So my next one is going to go down here, go down here. This one go down, so I'm going to have go down here and go down here, right? Okay, now the next thing's here, right? Okay, so let's see how do we do it, right? Okay, so the next one's here. So the x minus pi over 4 is here. Okay, so now let's still do this. So in here, pi over 4, what's that mean? That means I'm going to what? I'm going to shift to the right or shift to the left. I'm going to shift to what? To the right. How many units I'm shift to right? Pi over 4. Right? That means my 0 going to start at the pi over 4. Okay, now like look at the period, right? Okay. So period is a pi because here they have a 2 here, right? So that's why I will say the period will be pi over 2. All right. So now because they go to each side, so you said divide period by what? By 2. So what do you have here is a pi over 4 here. All right. Okay, so now let's take a look. How do we graph it, right? So this is my graph here. So this is a little bit bigger. Okay, so this is a pi over 2. This is a pi. This is negative pi over 2. This is negative pi. Okay, so let's take a look. They said the first things here, right? I'm shifting to the right. It's a pi over 4. That means what? That means my origins really shift to here, right? I'm starting here, right? So this is a pi over 4, okay? And now, because each end, right? So each end, so what is each end? Each end going to be plus pi over 4 and minus pi over 4. So I'm going to start at pi over 4. So plus pi over 4 is what? It's pi over 2. So I put an asymptote here. Pi over 4 minus pi over 4 is what? It's here, right? All right, so then my y-axis is shifted because I'm starting here, right? So now let's take a look at what is my tangent graph going to look like. So this is my tangent graph, right? So you start at the pi over 4, then you plus minus pi over 4. Let's do a next one here to see we be able to kind of the, see here, right? So this point is what? It's a pi over 2 plus pi over 4. So this is 3 pi over 4, correct? Okay, so then you know you're going to have asymptotes here. Then 3 pi over 4 plus 4 will be pi's, right? So if you want to repeat your graph, so then next time you're going to start here, right? So this will be a tangent function. Okay, so the same way, if I go up here, so okay, so it's a pi over 4. Now, what I'm going to do is here, pi over 4, right? So I'm going to plus, so minus the pi over 4, right? So this point I'm going to start in here. And then I'm going to plus pi over 4. So here. All right. Right, so this is a pi over 4, right? So the period is a pi over 2. So I move over to here, right? So that means this is how I'm going to start. So my next graph is going to go like this. right? So that's what is, how do you repeat your tangents, right? Because you shift to the right, then the pi over 2, right? So you say, okay, from the pi over 4, I add the, I go left, so I minus pi over 4 will give you negative. So this you starting here, right? So this is negative pi over 4 here. All right. So it's very careful and be, very careful about the, what you did here. Okay, so now, okay, so for this ones here, we need to be careful, right? This is kind of a little hard here. So in order to do that, so we need to be careful. So these ones here, we say y is equal to the 2 cotangent. So this is just, this 2 is easy. This 2 is just the vertical stretches, right? Okay, so now I need to go to find the period here. So this is a cotangent. So I need to factor the 3 out because I need to have a kx, right? So if I factor the 3 out, this will be x. So what is I factor the 3 out here? This will be what? Pi over what? Pi over 12, right? Because I take the 3, so this one will be what? 12, right? So the 3 times 1, 12 is 4, right? Okay, so now let's write. Okay, so here we're going to see here, you have a shift here, right? So minus pi over 12. So I said shift to where? Shift to right. How much shift to right? Pi over 12. Okay, now let's see the period. Okay, so the period will be what? Will be pi over 3, right? Because here, this is the number 3, here's k is 3. Okay, so because the cotangents, right? So I will say divide the period by 2. So what I have here is a pi over what? Pi over 6, right? Okay, so the pi over 6, this is the key things we need to, okay, so we need to graph here, right? So let's try to do this. Maybe we'll give a little bit bigger. Okay, so let's say this is a pi over 4. Okay, and so this is a pi over 4. And this is pi over 2, and this is 3 pi over 4. Okay, and this is pi is way back here, right? So this is a negative pi over 4, negative pi over 2. Okay, so the first things here, I'm shifting to the pi over 12. So the pi over 12 will be somewhere here. Pi over 12 is 1/3. Or maybe it's a little bit bigger. So it's 1/3. Okay, so pi over 12. So 1, 2. Okay, maybe this one is better. Okay, so this is a pi over 12, right? So this is the point, it's a pi over 12. So I know my graph has to start here. So this is a pi over 12. Okay, so I say I divide by 2, so it's a pi over 6. So where is the asymptote? Okay, so the asymptote will be pi over 12 plus what? Plus how much I shift to the right, right? So pi over 12 here. So this will be 12, and this is 1 plus 3 pi. Oh, so this is what? No, 2 pi here. So it's 3 pi over 12. So is pi over 4. Okay, so that's good. So pi over 4. So I'm going to have my asymptote here. So then the same ways here, right? So you can figure out the other asymptote. So you say the pi over 12 minus pi over 6. Okay, so if this is a minus pi over 6, you will get is negative pi over 12, right? So you will get a negative pi over 12. So negative pi over 12, let's try to graph the negative pi over 12 is here. So this is negative pi over 12. Okay, so I can have my asymptotes here. Okay, so now I know my sine cotangents, right? Also now also I need to times 2 here. So that means I need to be careful. So here this will be the 2 here. This is negative 2, right? Okay, cotangents go other way. So you go other way, and so if you take a look at your graphs here, right? So I'm going to start, so where? So it's a pi over 12, so here, right? Okay, so go back to your parent function. So this is what my cotangents here going to go, and then here, right? Okay, so if you want to, so if you don't remember, so go back to your first note here, see the cotangent, right? So the cotangents, take a look at the cotangents parent functions, right? So it's go this way, see here, right? So start at this point to go here, right? So go up there and go down here. And now here, that is how do I get a cotangents here, all right? Okay, so if you want to repeat several points here, you can do like this. So this is the, okay, so then you can have like 5 pi over 12. So it's a little bit in here. So this is the 5 pi over 12. So you just continue. And then you can do your graph here. This is the 7 pi over 12. So you can do your graph. It's kind of go like this, right? So, okay, so this is pi over 4, right? So then you go like this. All right. And then you can go like this. And then this one's here, you can go like this. All right. So that's just how do you do, the cotangents here, right? So that's kind of like, I think this will be my main graphs here. All right. So I need to use the blue color so I don't confuse you guys. So this will be my main graph. Okay, and this one is the one if I just want to repeat here. Okay, so it's the same things like we talk about the sine, cosine. Okay, so the last things here for the cosecants here. Cosecant and the secant, the same like sine, cosine, just they don't have amplitude, right? So for the functions here, so for the function y is equal to the a cosecant kx, and y is equal to the a secant kx for k greater than 0, then the period for both, going to, so both of them going to have the period. Okay, so we say the both have a period because they are the reciprocal of the sine and the cosine. So sine, cosine, the period is 2 pi. So both have a 2 pi over k here. Okay. Okay. So now let's take a look at the graphs here. This will be a little challenge. Let's see if we can do that. All right. So let's take a look at the first ones here. 1/2 the cosecant 2x here. Okay, so let's take a look at the cosecant. Go back to your parent functions, right? So the parent function cosecant is, so this is a pi over 2, this is a pi, this is a 3 pi over 2, this is a 2 pi, this is a negative pi over 2, this is a negative pi. So I know the what? So I know my cosecants here, the asymptote will be the pi over 2 and here. Okay, so the first things here, let's take a look at these ones here. So what is the period here? The period here is what? is a 2 pi over 2, right? So this is what is a pi. So remember the sine and cosine. After we do that, and then what do we see here? We say we divide what? We divide the period by how much? By 4, right? So it's a pi over 4. Then we draw pi over 4 for, we do the pi over 4. So for the graph here, so this is a pi over 2. So this is a pi over 4. Then this is 3 pi over 4 here, right? So this is a pi over 4. Okay, so we know the cosecant is going something like this, right? So if you do like your graphs here, you know your cosecant is do something like this, right? And go like this. And this is 1, but now you have what here? You have 1/2 here. So I know what I need to do here. So here they're going to drop down to 1/2, right? Okay, so now let's take a look at how do I graph it. Okay, so it's a pi over 4, right? So it's 1/2. So I need to start in the 1/2, going up here, right? And then the negative 1/2, right? So what I need to do here, starting here, going down, right? Look here, hey, my period here is pi, right? So I repeat, right? So I finished here. So if you want to repeat, so what you can do here, so this is how you repeat, right? So this is what is your graph going to looks like. And so for these ones here, this is how you repeat your graphs here. All right. Okay, so now let's take a look the other ones here. So this one here, y is equal to the cosecant, right? Cosecant is the, okay, so cosecant is the reciprocal of the sine. So it's like an easy one. Okay, so now let's try to write down the properties here. The properties here, right? So first thing, so this is a 2x plus pi over 2. In order to get this is a cosecant, right? In order to get a period, you need to factor the k out. So it's 2. So this is x. So if you take the 2 out, what is the pi over 2 become? Become pi over 4, right? Okay, so now let's write down what we have here. So what type of transformation? So first I have a shift to the what? Shift to the left, right? How much shift to the left? Pi over 4. I'm starting left. Okay, so then my period going to be what? 2 pi over what? Over 2. So it's pi. Then what I need to do, I need to divide by 4, right? So what is my each one here is a pi over 4. So then I also have, the constants here. So it's starting at 1/2 at y, right? Okay, so now let's try to see we can get this one down here. Okay. Always remember your parent functions, right? Okay, so here, it's a pi over 4. So shift to the pi over 4. So let's okay, so this is a pi over 4. This is add pi over 4. This is a pi over 2. This is a 3 pi over 4. This is a pi. This is negative pi over 4, negative pi, negative 3 pi over 2. All right. Okay, so now first we shift to the left, pi over 4. That means I'm going to start in here, right? So this is basically is my y-axis shift here. Then you need to divide it into a 4 interval. Each one is pi over 4. So I have this is my first interval, this is my second one, and this is my second one, right? This is my third one. This is what? This is my fourth one here, right? Okay, so now I'm shifting, right? So here, what is here? This is 1/2. Okay, so now let's take a look at my graph here. Okay, so here, right? So what I need to So what I need to do here? Okay, so my graph going to go like this, correct? Right? Okay, and then this one's here, I'm going to here. Oh, sorry, I need to go what? I need to go 1/2, right? So I did not do 1/2 here. So I'm going to do the 1/2 here. All right, so this is 1/2 here. Right, so this is my cosine, right? The cosecants, right? So this is my cosecant. And so if you want to repeat, all right, so if you want to repeat here, so this one's here, let me get rid of my color. Okay, so if you want to repeat, now let's take a look, where is my repeat? So my repeat going to start here, right? So I'm going to repeat like this way, or what you can repeat here, you can repeat like this way, right? That will be the cosecant graphs here. All right, so let's take a look at the last ones here. This is the secant, all right, secant. All right, so here, this one's here, this is the secant, no shift. Okay, so the only things here we have is 1/2, right? So let's take a look, what is my period, what is the period for this graph. So period here is what? So it's 2 pi over what? 1/2. So what is the period here? It's 4 pi here, right? Okay, since this is 4 pi, now I need to divide by what? I need to divide by 4. So what is here is 4 pi divided by 4. This is pi. That means each subinterval going to be pi. Okay, so then the next one's here, because this is 3, so we're going to starting at where? Starting at 3 for what? Y values, right? Okay, so now let's take a look. Okay, so this is the secant, so it's the inverse about the reciprocal of the cosine. All right, so because the period is 4 pi, so I said 1, 2, 3, 4, 5, 1, 2, 3. So I put here, this is pi, 2 pi, 3 pi, 4 pi here. Okay, so okay, so I'm going to, so each one, so should be a pi. So for each one, I use the dotted line to represent my subintervals here. Okay, now because it's 3, so I need to start at what? This is 3, and this is a -3 here. Okay, so now let's take a look at what is my function for this ones here. So go to your parent function. So I know this is the secant going to go here. Now how about here? They're going down to the -3, right? So we're going to here and here. And what is the last ones they're going to go? They're going to go here, the 3, they're going to go what? Right? So this is my secant main graph. So if you want to extend several repeat, you want to graph the other part. So what is this one going to be? So this one going to go up here. And what is this one going to be? This one going to go up here. And then this one is going to go what? Like this, right? That is how you repeat the secant functions. Okay, that's it. This is a pretty fun sections here about the graph of these 4, the trig functions here. Just be careful about the period, right? So the tangent cotangent period is pi. So you divide pi over k. Now, after you divide pi over k, the key things is because tangent cotangent, they just have 2 intervals. So you divide by 2 to get each subinterval. Then you can know where is the asymptote. But as for the secant cosecant, they are the reciprocal of sine and cosine. So after you find the period, then you divide the period by 4, then you can get the graph on each subintervals here. Okay. All right, that's it. And I really like this section. It's kind of like a fun section to graph. And I hope you got a pretty good idea how do you graph the tangent, cotangent, secant, and the cosecant functions. All right, our next ones here we're going to talk about is the inverse functions for those 6 functions here. Okay, you have a good day. Okay, bye.